Imagine looking so far into space that you're actually looking back in time. Now imagine discovering something that shatters everything we thought we knew about the universe. This is exactly what happened when the James Webb Space Telescope opened its golden eyes. What it saw left scientists stunned and questioning the very foundations of astronomy. The James Webb Space Telescope, better known as JWST, is not just another machine orbiting in space. It is humanity's most ambitious window into the universe. Launched on December 25, 2021, this telescope was the result of more than 3 decades of planning, testing, and international cooperation. Built at a cost of nearly $10 billion, Webb is the most powerful space observatory ever created. But why was it built? To answer one of the oldest questions we've ever asked, where did we come from, and how did the first stars and galaxies form? For over 30 years, the Hubble Space Telescope gave us breathtaking views of the cosmos. It showed us galaxies colliding, nebulae glowing in rich colors, and even helped measure the age of the universe. But Hubble had limits. It could only see so far, and only in certain types of light. Beyond that horizon, the universe remained a mystery. That's where Webb comes in. Designed as Hubble's successor, Webb isn't just bigger, it's smarter. Its golden honeycomb mirror is over 21 feet wide, almost 3 times the size of Hubble's. This mirror allows Webb to collect much more light, which means it can see objects billions of light years away with astonishing clarity. But Webb's true power lies in its ability to see in infrared light, the kind of light that is invisible to human eyes. Why is that important? Because the earliest galaxies and stars are so ancient, their light has stretched and cooled over billions of years, shifting into the infrared spectrum. To us, they are invisible, but to Webb they shine like beacons from the dawn of time. To achieve this, Webb had to be placed 1,000,000 miles away from Earth, at a location called the second Lagrange point, or LL2. Here it avoids Earth's shadow and can keep its instruments cooled by a massive sunshield the size of a tennis court. Without that cold, Webb's sensitive detectors would be blinded by their own heat. Every part of Webb was designed with one goal: to look deeper into space and further back in time than anything ever built before. It is not just a telescope, it is a time machine. With its eyes fixed on the stars, Webb's mission is to witness the birth of the first galaxies, to uncover how the universe evolved, and perhaps to bring us closer to answering the ultimate question of how it all began. When we gaze at the night sky, it feels like we're looking at stars in the present, but in reality, we're seeing the past. Light doesn't travel instantly, it takes time. The light from the sun needs 8 minutes to reach Earth. The glow from the nearest star outside our solar system takes over 4 years. Every time we look up, we're looking at history written in light. Now imagine stretching that idea to the extreme. The James Webb Space Telescope was designed to catch light that has been traveling for more than 13 billion years. That's almost the age of the universe itself. In other words, Webb is not just observing stars, it is peering into the very first chapters of cosmic history. Scientists call this era the cosmic dawn, the moment when the very first stars and galaxies began to shine after the Big Bang. Before this dawn, the universe was a dark ocean of gas and particles. There were no stars, no galaxies, only silence and shadow. Then gravity began to gather matter into clumps, sparking nuclear fires that became the first suns. But here's the challenge. The light from those ancient stars has stretched during its journey. As the universe expanded, the light waves grew longer, shifting out of visible colors and into infrared. This is why Webb's infrared vision is so critical. It allows us to see what Hubble never could: the faint, red-shifted glow of the earliest galaxies. So when Webb peers into deep space, it is literally looking back in time, billions of years before Earth existed, before the sun was born, before even our Milky Way had taken shape. It is our time machine to the universe's origin story. When the James Webb Space Telescope began sending back its first images, scientists expected beauty, and yes, the pictures were breathtaking. Spiral galaxies glowing, star nurseries bursting with color, and clusters of galaxies bending light itself through gravity. But hidden inside those images was something far more shocking. In the deepest scans, Webb revealed galaxies so distant, so ancient, they existed only 300 to 400 million years after the Big Bang. To put that in perspective, the universe is about 13.8 billion years old. These galaxies appeared when the cosmos was still in its infancy, just a few pages into its story. Now, here's the shocking part. These galaxies weren't tiny baby systems, as theory predicted. They were massive, containing billions of stars, some nearly as large as our own Milky Way. According to everything we thought we knew, galaxies simply shouldn't have grown that fast. Think of it like this. If the universe were a human being, these galaxies would be newborns, but already the size of adults. Astronomers had expected small, chaotic collections of stars at that early stage, not giant, well-formed galaxies. The discovery shook the scientific community. Entire models of cosmology, the science that explains how the universe formed and evolved, suddenly looked incomplete. Our textbooks told us galaxies take billions of years to grow through slow mergers and collisions. Yet Webb was showing us massive galaxies thriving less than 500 million years after everything began. For some scientists, this felt like staring at a puzzle with missing pieces. Did galaxies form faster than we ever imagined? Or are we misunderstanding the very nature of the early universe? Webb's images weren't just beautiful, they were disruptive. In that moment, the telescope had done exactly what it was built to do, not just to give us answers, but to challenge our questions. Science is built on rules, patterns we discover in nature, tested again and again, until they become laws and theories. For decades, cosmology told us a clear story of how the universe unfolded. After the Big Bang, matter slowly gathered into stars. Stars merged into small galaxies. Over billions of years, these small galaxies collided and grew into the giants we see today, like our Milky Way. It was supposed to be a slow and patient process, but the James Webb Space Telescope changed that story. When Webb revealed galaxies that were already massive, only a few 100 million years after the Big Bang, it was as if nature had skipped ahead. Galaxies that should have taken billions of years to grow were somehow racing through the timeline. According to the rules, they shouldn't exist so early. Yet there they were, shining clearly in Webb's infrared eyes. This breaks more than just expectations. It challenges the very foundations of the models scientists have trusted for decades. If galaxies formed too quickly, then our understanding of matter, energy, and cosmic evolution might be incomplete. The carefully drawn map of the universe's growth suddenly has blank spaces and question marks. Imagine planting a seed and finding a full-grown oak tree in your yard the very next morning. That's how astronomers felt when they saw these galaxies. Something fundamental didn't add up. Some researchers began to wonder, are we misinterpreting the data? Could these objects be something else entirely? Or is it possible that the rules of physics in the early universe were not the same as they are today? One thing is certain, Webb's discoveries forced the scientific community to pause and rethink. The universe was not following the script we had written for it. Instead, it was writing its own faster, stranger, and more mysterious than we imagined. The rules we thought were unbreakable may only have been temporary guidelines. When the James Webb Space Telescope revealed massive galaxies in the early universe, the discovery sent shockwaves through astronomy, but science never stops at shock. The next step is always the same: search for answers. The first possibility is simple. Maybe we misunderstood what we were seeing. Could Webb's data be misleading? Some scientists suggested that the bright objects detected might not be galaxies at all, but other cosmic phenomena. Perhaps black holes or unusual star clusters tricked our instruments into thinking they were galaxies. Careful follow-up studies are still being done to confirm exactly what Webb has uncovered. But if they are galaxies, then the universe must have grown far faster than we believed. How could that happen? One idea points to dark matter. This mysterious, invisible substance makes up most of the universe's mass. If dark matter clumped together earlier, and more efficiently than expected, it could have accelerated the growth of galaxies. Another explanation could lie in physics itself. Maybe the rules we know today about gravity, star formation, and cosmic expansion were slightly different in the universe's first moments. If so, the early cosmos may have been a far more energetic and efficient place for creating stars than our current models predict. There is also the possibility of entirely new forces or unknown particles at play. Some researchers even wonder if we need to rethink the Big Bang timeline itself. Could the universe be older than we think, or did structures form in ways we simply never imagined? Whatever the explanation, one thing is clear: Webb hasn't just raised questions about galaxies, it's raising questions about the very foundation of cosmology. The telescope has thrown open a door, and behind it is a universe stranger and more complex than we dared to dream. Science lives in these moments, not when everything fits neatly, but when discoveries force us to think bigger, dig deeper, and accept that our story of the universe is still being written. Science may deal with numbers, theories, and equations, but at its heart, it is a deeply human journey. Behind every discovery made by the James Webb Space Telescope are scientists, engineers, and dreamers who spent decades bringing this machine to life. For them, Webb's shocking images were more than data. They were emotional. Imagine dedicating 30 years of your life to building a telescope, overcoming delays, failures, and doubts, only to see it finally unfold a million miles from Earth and reveal something no one expected. For many astronomers, the moment Webb's first images arrived was overwhelming. Some described tears in their eyes. Others admitted they could hardly breathe as they realized what they were looking at. And then came the shock. Galaxies too large, too early. A challenge to everything they had taught students, written in textbooks, and believed for decades. For scientists, this is both humbling and thrilling. To realize that nature is not following the rules you thought were fixed, it's a reminder that the universe is always ahead of us. But this shock is not discouragement. It is fuel. Scientists live for moments like this, when the universe forces them to rewrite the story. Instead of disappointment, there is excitement. Every surprising discovery means we are one step closer to a deeper truth. It also reminds us of something bigger, that our species is still in its infancy when it comes to understanding the cosmos. We build machines like Webb not only to answer questions, but to awaken wonder, to remind us that we are part of something vast and mysterious. For the men and women studying Webb's data, these discoveries are not just about galaxies billions of light years away. They are about us. Our curiosity, our courage, and our endless desire to know where we came from and where we are going. The James Webb Space Telescope was built to look deeper into space than ever before, but in doing so, it also looked deeper into time itself. And what it found has shaken the foundations of our understanding. Massive galaxies appearing too early, stars blazing long before they were supposed to exist, a universe that refuses to follow the rules we carefully wrote for it. Each discovery Webb sends back is a reminder that the cosmos is not simple. It is complex, unpredictable, and far stranger than we ever imagined. But that is the beauty of exploration. We build machines like Webb not to confirm what we already know, but to discover what we don't. Each surprising galaxy is not a problem. It's an opportunity, an invitation to rethink our theories, to test our assumptions, and to accept that the universe is under no obligation to fit neatly into our expectations. For humanity, this is more than science. It is a story of curiosity, courage, and vision. Webb's discoveries remind us that we are explorers reaching beyond the boundaries of Earth to ask questions as old as time itself. Where did we come from? How did it all begin? And what else is out there, waiting to be found? The answers may take years, even decades, to uncover. Scientists will argue, test, and rewrite. But that is the journey of knowledge. Step by step, discovery by discovery, we move closer to understanding our place in the cosmos. So when you look at Webb's golden mirrors, remember this. They are not just reflecting light from distant galaxies. They are reflecting us, our desire to know, our hunger to explore, and our willingness to be humbled by the vastness of the universe. The James Webb Space Telescope has only just begun its mission, and if its first discoveries have already rewritten the story of the cosmos, one can only imagine what shocking secrets are still waiting to be revealed. The story of the universe is still unfolding, and we are here to witness it.